Well, that's the right way to start off the video. So I'm just going to go ahead and take this Win 7 virtual machine that I have installed with the SQL Developer on it. And I will open up SQL Developer here once the machine state's restored and show you the script files that I wrote in SQL Developer in order to create tables and seed the tables and run queries in order to, create tables and then queries to show that the information was in there correctly, and we can track people's times by their projects per task or however we want to do it. So while this is opening up, I'll show you right here. I've put into text documents all of the information with the table creation script right here, and then this is the seeding script, or putting the information into the tables. It's pretty lengthy. So if you guys wanted to, it would be very easy for you to just take these script files that I've created, change the file format to .sql instead of .txt, and you could open them up into your SQL Developer, and they'll open up as like a script file in your Oracle SQL Developer, and then you can run them yourself, and it will do the exact same thing that it would do on my side. However, since I'm not at school, I'm on my home desktop right now, I actually can't run them, unfortunately, but I can explain everything that's going on in them and what you would be seeing at the bottom of the screen in order to better understand what's going on here, if this ever loads. What the heck? I wonder if my Internet Explorer actually works inside the virtual machine, because sometimes the internet's sketchy. Oh! It's working. It's awesome. Something I recommend always doing too, whenever you're in a virtual machine while this is loading up, you guys may not know, is using the guest edition CD or installing the guest tools. This installs a whole bunch of features onto the guest or the virtual machine that allow you to do a whole lot of different functions. It allows you to copy and paste between the host machine or your desktop and the virtual machine's desktop, or any file directory. Really helps you copy and paste between, and helps you go full screen like this, whereas if you don't have them installed you can't. So you insert the guest CD, and then you would go look right here, and here it is, it's right here, and then you just have to run the installation. Very, very helpful. Okay, so we have this opened up and it restored my previous state, I guess. Although it doesn't have my seed script open. This is just a little sample script that I'm running. I wonder why he had us install an instance of stinking Windows 7. Like, this is the most inefficient thing that you could run inside of a virtual machine. It's so slow. It's just death. Let me open up the What's the meaning of this? Just open it. It's so slow. It hurts. It hurts! I have a beast machine too, okay? This is just straight up Windows 7 stupid. In a VM. Running Windows 7 within a Windows VM. It's like perfect sense. Okay. Now let's start explaining what's going on here. Now that we've been waiting around for like 4 minutes. So this first, can I just get into the text editor? Would you just change focus already? This is incredibly frustrating. I'll just start trying to explain as much as I can. The first line here, I don't know if you can read it or not. I hope you can. I don't know if I can like zoom in or what, because nothing's moving. This is just terrible. I'm going to turn the music off too over here. That way YouTube doesn't give me a content claim or whatever the heck. Just close everything I can, although I have a feeling it's just Windows 7 is not made to be ran in a virtual machine. Okay, here we go. So this first command right here, usually at the bottom of the screen, you'll have something, you know what? Yeah, I'll just start here and then I'm going to go into Notepad and just explain what's going on, because it does work. This right here clears your output, which is usually a screen down here. And what I'm doing up here at the top is I'm dropping all of the tables and sequences that I've created, so that way when I rerun the script, I don't get the error saying this table already exists. And so that way if I ever need to make any changes while I'm trying to create a database or a schema, or whatever you want to call it, you're able to really easily make those changes, rerun the script, delete all those tables, and recreate the new kind of schema or setup that you have going, so you can delete all those first. Now you might have asked, okay, what is a sequence? I know what a table is. Table kind of has those columns, and then you insert rows of information in those tables. In class, we've talked a little bit or touched down on what a primary key is. So a primary key is a unique identifier of a row within a table. And we haven't really talked about it yet, but one of the most ubiquitous and best primary keys is just an auto number. And that is to say that whenever a new row is created, it's just the same number of the previous row incremented by 1. So the first record would be 1, second record would be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, going on to however many records you're going to have in that table. And it's just a good practice to do that. And so a sequence is essentially keeping track of that auto number and where it is. So you need to drop the sequences as well, so that way if I have previously created records 1, 2, and 3, that when I recreate the database, I don't start at record 4. I'll start at 1 again, because I dropped the sequence and then recreated it. Let me go into, because I know I can zoom in with this and you'll be able to see it more easily, right? So here's those that I was talking about. Actually, I think I can open the SQL script with Notepad++. There we go. Now it has some, can't remember what it's called when stuff's highlighted. So now I have some commenting out. You can comment out in SQL by doing the ... for a line, or if you wanted to comment out a block of text, you can use /*, and then where you want it to stop, you can use */. So the standard way of creating a table is just create table, name of the table, and then you have your parentheses and you say row 1, type, and then constraints, essentially. And then if you want to do another one, you need to do comma space row 2. I did this backwards. It should be alright. And that's pretty much really straightforward how you create a table. And at the end of the SQL statement, you always want to do a semicolon, like you see here, 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 right on those names. That's essentially saying run this, or that this is actually, it's not saying run this. It's saying that this is the end of this statement. So what we have here is create table employee. Now, as we go through this, you're going to see that I created the employee table first. I drop it last. I create the project table second. I drop it second to last. I create task table third. I drop it third to last. I create employee task table fourth. I drop it first. And that has to do with drop dependencies and the order in which you are allowed to drop and create things within a database or relational database model. So we're going to go ahead and I'll just show you the example of this create table. So we say create table employee, so this is the name it would be known by. I create the field employee ID. If you guys look back at the email that I sent you earlier, I think it has the logical design, the ERD in there, and all of this information is pretty much in there. The only thing that may not be there is this. It says number in here, and that's an Oracle thing. In most other databases, you would have to define what type of number value it is, but I don't know. Oracle just likes to say number. They want to figure it out and store it in there. I have to. It's weird to me. And then I'll have inside the parentheses of the varchar how many characters the varchar can be. And pretty much everything's not null. So we have our employee ID number, not null, name first, name middles, name last. This in the ERD is actually name last, so I messed up on that, but shouldn't be a big deal. Now here's something that is different. We have a constraint. So this says constraint. I'm essentially creating a new constraint, and I'm naming the constraint PK employee. And then I'm saying primary key. It's the type of constraint is a primary key, and the field that this primary key is employee ID. So I'm creating a constraint for a primary key called PK employee, and the primary key is the employee ID. So that's something different. That's usually what you do at the end of a lot of fields. Yeah, I'll leave it at that. This is create sequence, so I'm creating that auto number tracker for the employee ID field for when we create a new record. And I'm going to be doing something weird. I'm just starting with the number 100,000 and I'm incrementing by 10 just because employee numbers usually aren't, like 1, 2, 3, 4, 5, 6, whatever. Same deal over here with project, except the sequence starts at 1, is incremented by 1. Here we have project desk, which is going to be a short description, and then project description, which would be a long description and entail far more details about what's going on. Sequence again. Now there's another thing that's a little bit different on this create table task, because task contains a foreign key, which is the project ID. So task ID is the primary key, and this is the foreign key. And as you can see here in this line, I'm creating another constraint, right? Creating constraint FK project ID, so that's the name of the constraint. The type of constraint is a foreign key. Okay. Now the foreign key within the task table is project ID right here. Now this foreign key, it always references another table. So you say references table, which is the project table up here, and it's referencing project ID. So what that's saying is whenever I create a row in the task table, the project ID has to be required. There has to be a value in there because it's not null. Null means empty or non-existent sort of. And it has to match a value that already exists in the project table. So if I only created project IDs number 1, 2, and 3, I couldn't go into the task table and say create task ID 1, project ID 4, because project ID 4 doesn't exist. Sequence again. And employee task, it's the same thing. We have our primary key, but this time we have 2 foreign keys. And it's the same thing as it worked on the previous one. And so we have this structure now set up that is, I guess I don't have it with me, but I can just open it here. Oh, why did I do that? I don't want to look at that. Oh, it looks alright, but I'll download it anyway so that way we can look at it. So essentially, I've created a physical representation of what's going on here. And the way that I've done it, oh, this little line right here should be attached to this PK, not to this little line. I'm goofed up there. It's okay, he won't even notice. So whatever we can figure out in terms of functionality of what we could get out of this, that's actually going to happen with what we do in that within that script. So if we run this within SQL Developer, it's going to create that picture that we just saw. Now, if I go to I don't want to make any changes on that. Seed script, no changes on that. Now let's look at the seed script. So now we have these tables and everything, but they don't have any information in them. It's just a shell. Now, remember how I said, oh dang it. Don't steal any of that. That was all proprietary. On this create, I was mentioning the order in which we created some of the tables and how we would have to drop the tables or get rid of them. This holds true for the order in which we would need to seed the tables or put information into them. So for example, I could not create a record in the task table before there is a record in the project table. And the reason I can't create a record in the task table before the project table is because the task table requires a project ID. So if there is no project ID or there's no project that has been created or instantiated, I can't create a task because it has to reference something, but it can't because there's nothing there. So I have to follow this same order in my seed script. And we'll see that we do that here. So I'm inserting an employee first. I'm inserting a few employees. And then I did a, checked anyways. And then project. And then I'll do tasks. And then I'll do some employee tasks. Or a whole lot of employee tasks. And then I do some select statements, some pretty complex select statements that I will explain to check that the information has been inserted in the way that I wanted it to be inserted. So if we go all the way back up here into the top, we'll see that I clear the screen. I'm just clearing the output so that way I don't, see a whole bunch of nonsense from previous scripts that I've ran. And then what I'm doing is this little @ symbol right here is essentially saying run a file. Run a file. And what I'm telling it to do is to run the create script.sql file that is in the same directory. If it wasn't in the same directory, I would have to do something like this, different directory. If it was in a different directory, but it's in the same directory, so I can just do @create script.sql. Now what this is doing is cool. I can just run the seed script, and then it clears the screen, and the very next thing it does is it opens up the create script, clears everything out, and clears everything out with the drop tables, right? Any information that maybe previous was in the tables is now gone. I guess it could be a good thing or a bad thing depending on if you've actually been using this database or not. You clear it all out, and then you go through and you recreate the whole structure of your database. That's just good practice, so that way you clear out all the tables and everything, so that way when you're trying to run your insert, you're not getting duplicate records and weird things. It's just good practice to clear it all out and then do it all over again, so that way it's functioning the way that you want it to and you don't have any weird strange errors going in. So I created some employees here. Now what I did here is this is the normal way, the normal prototype that you do an insert statement, very straightforward. Insert into employee values, and then you state every column or the value that you want for every single column in that table. Okay, so we'll go to the employee table to just take a look at it. So we have employee ID, name first, name middles, name last, charge rate. Okay, so we have to put everything into all of these except for names middle. However, if we don't want someone to have a middle name, like right here for Darian, for example, we have to put null. We can't just, oh, well, we don't want anything in there, so we'll just leave that spot empty. No, because then it will just say, okay, first name Darian, middle name Huang, last name 45, number 45, and then it'll say, but wait, where's the charge rate? We have to have a charge rate. So if you're doing it this way that I've done, you have to have a value for every single column. Now let's just say I just wanted it to do employee ID, employee, oh wait, no, that's not right. Name first, name last, and charge rate. And I didn't want to have a middle name. Well, then at that point, there, perfect. I'm telling it what rows I want to insert into. It's also important to remember if a column is specified as not null, then you have to insert something into it, or it'll say, sorry, too bad, can't do that. Okay, so that's the basic. I hope that makes sense. And then I insert an employee. There's Darian, George, and Chase. So we're all in there, and George makes the bank, and we're all mad at him because he makes more money than us, and we think that he does less work. so we try and get him fired, because then we'll make more money. Okay, so now I'm doing an insert into project. It's the exact same thing. So what I'm saying here is I'm inserting into a second level table. That means that this table will require information. No, wait, that's not true. I've only got one project. I should have two projects. That's right. So I do a project here, and then I insert the related tasks, and then I insert a project here, and then I insert the related tasks. So here, this will make sense. So I create I create my first project row. Oh, something I didn't explain. Let me go back to employee right here, right? Remember that sequence I created? It was called employee ID sequence _sequence. Now it starts off at 1 or 0. Anyways, I can't remember. To pretty much keep it consistent, you usually just do .nextVal, and that'll give you the next number in the sequence. So whenever you do .nextVal, it'll give you the first number. So for this one, for example, the first number would be 1, right here, and then this time it's going to be 2. So Darian's employee ID is 2, and mine would be 1. Okay, and it just keeps going forward like that. So yeah, so I create the project ID. The project is going to have a short description of time clock. The long description is create a system which will record employee clockable hours. Should have space there. Now I'm going to insert records into the task table that are related to the project table. Now I could do these later. I just wanted to do it this way because it, to me, was an easy way to group to understand, to see what tasks, to see that these tasks belong with this project. I could have done the tasks at the end. I could have done employees, then projects, then tasks, and then employee task. But I wanted to do it this way because it made sense to me. So I'm doing the next task ID. And here's another reason why I like to do it at the same time. I create the first task, which is going to be task number 1, and then I can say projectid.sequence.current value. So that'll take the currently instantiated value in the project ID sequence, and that will insert it into the table at this point. So what's going to be inserted into this column of the row that we're creating is 1, because this was the first project ID key that we've created. Create a logical design. Okay, this is the task. We have to create a logical design, and the long description is develop a development production. Oh yeah, okay, that makes sense. Develop a development production workflow in conjunction with a logical design. I cannot English. Decide on what platform we want to develop. Now here's something helpful to know, so that way our code doesn't span super long off to the side of the page. That's that way. This is the, oh my gosh, what's it called? What's it called when you connect 2 lines of string? Anyways, it's like the ampersand for most programming languages, and sometimes plus sign. It connects lines of string. Connector, conjunction, function. What's your function? Anyways, use the double pipes to connect string in SQL statements. Then I created the next task, which is create a physical design. Implement the system onto the Visual Basic platform. That's the next task. Create another project, csgo.simplified database. Create a database which parses CSGO demo files into raw data for analysis per user request. Related tasks. Create the logical design of the CSGO simplified database. And as you can see, we're using the current value. So this one is going to be 2, because this is the second project. This is project number 2. This is going to be task ID number 2, and this will be task number 3, because we had 2 tasks up here, right? 1, 2. Task ID number 3, which belongs with project ID 2. Create logic design workflow. Okay, create a physical design, implement planning phase, and system contract for member revenues. Same, just different projects. Same task, I guess, but a little bit different. And then this would be task ID 4, number 2. So I did some checks here to make sure that everything got inserted before inserting into the third level table, which essentially requires there to be information in project, task, and employee in order to, well, I should say requires information in an employee project task in order to insert information into employee task. And again, we're just using this, and I just hard-coded values right here because I know that there's number 1 and that there's employee number 100,000, and then he spends 12.5 hours on that task. And then if I want to know, okay, well, what task is he spending time on, I can say, okay, he's spent task on task number 1, and go all the way up here and see, oh, okay, he spent 12 hours on creating a logical design workflow in conjunction with the logical design that belongs to project, okay, number 1. Normally you can do something more sophisticated and elegant by putting a query in here that will help you find the number. It'll return the number that you're looking for, but that's a little bit complicated. I wanted to keep it simple. Right, so I hope that makes sense. This is just another insert employee task values. And I do that so that way I essentially create a whole bunch of hours on different employees. Then I select all from employee task, and that shows us that the records were inserted correctly into the employee task table, and also it'll help us determine that things have been inserted correctly into the task table and the project table, because we could not insert into the employee task table if those other tables do not have correct information in them. Now here I'm doing a pretty complicated select statement. So I'm saying select first name and last name, and then I want it to display in the return, or in the result set, I want the column on top to say name, and the name will be their first name, a space. What is it called when you connect strings? Anyways, it's driving me crazy. You should know this. There's a space, and then their last name. And then I want the charge rate, I want it to show as rate, and then I want the number of hours they spent as hours, and then I want a column where I multiply hours by the charge rate as total, or how much did it cost me to have that person working on X task, something like that. Okay. Now I'm selecting it from the table ET, and then I'm joining it to the table E, and then I have to say how I'm joining them. That's complicated. Let me show you a simple statement. Select name first, name last, charge rate from employee. This is a much simpler query. Now all you're doing here is you're going to return all the records from employee. I'm going to do this. Makes it leads into the next query a little bit better. All you're doing here is you're saying, okay, from the employee table, and you usually read queries backwards. It's really funny. The order that it will go search for this information is it'll look to the table first. It'll look if you have any conditions underneath here, filters, I guess you could call them. Then it'll apply those filters and get the records that will apply, or it'll get the records first and then apply the. Yeah, it's from, select, and then filters, pretty sure. So from the employee table, known as E, in our query, we're going to name this table E. We want to select from the employee table, name first, from the employee table, name last, and from the employee table, charge rate. And that'll get us some values returned. This is not too different. So what we're doing here is we're saying from the employee task table, and I want to join that table with the employee table. So I'm going to just take every column where essentially what's going on is whenever there's a column in employee task and there's a foreign key that has employee ID, I want to be able to display information from the employee table that is the foreign key relation inside of employee task. So let's say, for example, in employee task, we said George worked on task number 2 for 13 hours. But in the employee task table, George is not known as George. He's known as number, I think, 3. So instead of seeing 3 in the result set when we run this query, we want to be able to see his first name and his last name. So we have to say, okay, we need to join the employee task table to the employee table, and we join them on the employee task table employee ID equals the employee table employee ID. So where employee task in the employee task table, the employee ID is the same as the employee ID up here. So it joins them and gets some cool results. So I did that just as a little check to see if I remembered how to do queries. It worked. And then I did a very, very complicated query here. Well, not very, but for us it's very. I'm taking the sum of the hours, sum of the total, and yeah. So I'm just getting the total number of hours and the total cost. And I'm making it, the total hours and then the total cost. And I'm doing that from this query, which this query is this query. I just said from, and instead of going to a table, I'm essentially going to this result set, the result set that's generated from this query, and then I'm saying from that result set, I want the hours. I want to sum the hours, right? So I said the hours right here, I want to sum those hours, and then I want to take the total, and I want to sum the total. Now I've named this, like you see how I said employee E? Or no, better, from employee task ET, I'm saying from this result set grand total, and I'm naming this grand total. So that's how it knows what hours I'm referring to. I'm referring to the hours from the grand total result set, or view, temporary table. And this gets us the total number of hours and other things like that. If we need to, I can whip up a query very quickly as well to break it down to how much cost it's going to be per task or how much cost it's going to be by project. We would just need to do another inner join and say inner join on task, and then we could get what the task description is, and we would group by task, and then it would say task 1, or the task short description, number of hours, the total, and we could see how much we're spending on task. Or if we didn't want to do that, we could group by project ID. We could do inner join to task and then inner join from task to project. I hope that it's kind of complicated. Maybe we'll get a chance to show you a little bit on Monday, but I can't actually run this. I swear it works. I can't run this right now because I don't have VPN to the school. Should try and do that sometime. But yeah, it all works. Yeah. Alright, well, this has been a really long video. I hope it's been very informative. It's probably a lot more than we're going to get out of the whole semester of Mark's class. Good luck.